Good afternoon, everyone. Just jumping into a quick video to show you how a stack's created, how to find where everything is on the stack, and then with that knowledge, you should be able to go on to do a buffer overflow, which I will cover in my next video, a simple buffer overflow. So let's get down to business and let's get our terminal fired up here. So the first thing I'm going to do is show you my Oops, that is the compiled one. Let's do .c. And here's my little C program. It's got an argument counter, an argument vector, so we can put in a little argument. It's got int A and int B, 10 and 20, and a string, my string pointer that says hello, and then a return 0 to libc. So just a very simple program. What I'm going to do is haul it apart in GDB, which is a debugger, and I'll show you how things work inside the stack memory and how to find things within it. So that's all messed up. Let's try this one. GDB-Q. I put in Q so I don't get the comments on the top, and it just makes things look prettier. First thing I'm going to do, disassemble the main function. And as you can see, everything's into beautiful assembly. We can see the epilogue right here. We can see the base pointer being pushed onto the stack. We can see the stack pointer being pushed to the base pointer. And then we can see subtract it from the stack pointer 0x18. So what is 0x18? What's happening there? We can do printf. Whoops. Bear with me. We can do printf. And let's do a decimal D / new line. And what is 0x18? As you can see, it is 24. So we got stack creation of 24 bytes right there. So this is the creation of the stack right here. There's a few assembly commands here that you don't really need to worry about. And then once we get down to the right here, it starts pushing our integers and our stack pointer to the stack itself. So might sound confusing. It's really not. What I'm going to do, I'm going to display two integers of EIP, which is the index pointer. Index points to what is, it shows you what's going to happen next. And it's always moving to the next part of the function. So I want to see that. I also want to see, let's do 8 words of hex from the ESP, from the stack pointer. And this will let us have a good look at the stack as we roll through here in our debugger. I'm also going to set a breakpoint right here where the base, just before the base pointer or the stack pointer gets put where the base pointer is. So all you do is B* for break, and then let's paste this in, and our breakpoint's there. So what I'm going to do, I'm going to run with arguments AAA, and let's go. Okay, so the first things first, let's find where our stack pointer is. So let's do WX or examine word in hex. Where is our stack pointer? So as you can see, this address right here is the top left corner address right here. This is where our stack pointer is. Let's have a look for a base pointer at this point. As you can see, 0. It's not there yet because this is the next move, is going to move the stack pointer towards base pointer. Okay, that'll be at the same address. So let's hit next instruction. And let's have a look at where our base pointer is now. It wasn't around. Now, boom, it's at the same place as the stack pointer right here. Okay, so our stack pointer and our base pointer are at the same place. Next instruction, ESP. This is the index pointer here, the next 2 instructions. It's going to push 0x18 onto the stack. So that's 24 bytes right there in hex. So what we will do is hit the next instruction. Let's do that. Now, as you can see, that address has moved on the way down here, and this is where our new base pointer is. So what we can do examine EBP. As you can see, the EBP is now down here. So where is our stack pointer now? So let's find out where our stack pointer is. And as you can see, is this top address right here. And then we have 24 bytes, 4, 8, 12, 16, 20, 22, 24. This, or 24, this is our stack right here. So what I can do is also, we can print EBP minus ESP. Whoops. And as you can see, our stack is 24 bytes. So now there's a few instructions here that are just some assembly stuff. It's just zeroing out the EAX register and moving things. Don't really need to pay too much attention. Once we get down to these double word pointers, this is our stuff starting to go on to memory. So 0xa, which is our 10, is going to be at EBP minus 4. So we already know where EBP is. It's right here on the stack. So EBP minus 4 bytes is this address right here. So let's hit next instruction and let's see where that goes. There you go. So now our 0xa is at this point right here. Okay, so next is going to be the 20, and that's going in EBP minus 8. So here's EBP for 8. So that should go into this part of memory right here. As you can see, 0x14 moved in there, no sweat. Next double word pointer is EBP minus 12. This is not hard stuff. It's going to be going up here. This is an address, though. I'll show you. It's not our string. Our string will be a little different here in the assembly. So here's an address with our string, though. So let's hit next instruction. And as you can see, this place up right here, let's have a look right here. Let's copy it. Let's have an examination of this one. And as you can see, is a hex string. And it backwards is HELLO. Hello backwards in hex. Okay, so that's how strings get stored. It gets stored backwards, little Indian convention, the hex. Okay, so what are these other two here? Here's our argument counter. Had we put in arguments, it would have shown up here, and then in the second examination of hex 2 WX, you would see the argument count and then the argument itself. Right here, what's this one? Let's have a look at this one right here. You can probably guess what it is right now because it's probably the only part of my stack.c that we haven't covered. So let's put in this one right here. And this is return to libc.main. This is our return 0 at the end of the program. So that is how that little program stacks up on memory. When you get into buffer overflows, you got to know where all these things are to overwrite them with your malicious software and all that fun stuff. So I hope this gives you enough information to look around on the stack yourself, and I hope you understand stack a bit better. I'll be covering buffer overflow later this week, just a vanilla one, old school 2001 stuff. I hope you guys have a great day. Take care. Bye.